Oh, this is our first definite integral question. This one is really easy, from easiest to the hardest one. The integral of cotangent x dx from pi over 4 to pi over 3. So this one is really easy. If you don't know how to integrate cotangent x, you can check my other videos. And this is ln absolute value of psi x, and then we're gonna put pi over 4 and pi over 3 into it. So you will get ln, and then psi pi over 3 is what? This is square root of 3 over 2. Or you can, this is the answers, I guess. And here we just need the parentheses here because it's always gonna get positive here. Psi pi over 3 and pi over 4, and then subtract ln of, this is just algebra, and this is square root of 2 over 2. I like to rationalize. You can also write as 1 over square root of 2, up to you. And because this is our L1 log property, L1a minus L1b can get divided square root of 3 over 2, and then divided, you just need to multiply by the reciprocal of it, 2 over square root of 2. So you can get 1 over L1, 2 and 2 they cancel each other, and then this is L1 parentheses of 3 over 2, because you can square root of this, and then this is 3 over 2 raised to the 1/2 power, you can put a 1/2 in front of it, and then that's the answers. Yes, 1/2 L1 of 3 over 2. And we don't need a plus c here because this and definite integral. Definitely integral. What is really hard to erase, which is our finger to erase it. I don't like it. So our number 14 question. This one is the integral of x cubed ln x dx from 0 to 1. And to integrate it, I would like to use our integration by part. Put a d and I here, and don't forget the plus and minus, and then we're going to differentiate ln x and then integrate x cubed. The reason we don't integrate ln x because we have to do another integration by part again, so I don't like that. So to differentiate ln x, you get 1 over x. To integrate x cubed, you get 1/4 x power 4. So it's become 1/4, and then x power 4 times ln x, and don't forget to put the lower limit and upper limit inside it. So I'm not sure I wrote the wrong answer because ln x, but don't worry. You replace 0, you get the answers here, right? So don't worry, and then minus become positive, plus 1/4, and then x power 4 divided by x is become x power 3 dx. So here we're gonna get 1 over 4, and then put 1 inside, you get 0. Entire you get 0. The first one you get 0, right? L1 1, and then subtract by, and then put 0 inside, you get 0, and then L1 x here you get negative infinity. 0 time negative infinity is an indeterminate form, so we're gonna do some more work. We're gonna take limit at x approach to 0, not infinity here. It should be 0, and then let me do another 1/4 here, and then we're gonna limit at x ln x over x power negative 4 here. So if you put a 0 here, you get negative infinity over 0. This and indeterminate form. So we're gonna use our L'Hospital rule. L'Hospital rule. I don't know how to pronounce this, but don't worry. So you can get, if you differentiate Ln(x), you get 1 over x. If you differentiate x power of -4, first you put a power here and then you minus the power, so it becomes -5. And then we're gonna simplify it. Just multiply by x on both sides. And sorry, it should be infinity. Because when the plus 0, I don't like the answers to be infinity or indeterminate form, so you're gonna let limit x approach to infinity here. So you get limit at x and then 1 over, and then x times that you get -4 and then x power -4. If you put infinity over, you get 0. So entire you get 0 minus 0 here. And then plus 1 over 4 times 4 divided by 4 here, 1 over 16 x power 4 plus 0 and 1 inside. So your final answer is 1 over 16 and then minus 0 here. So this is answer true. Let me check it. Minus. Let me use our Photomat. Negative 1 over 16. Wait a minute. Minus plus, but why this is negative 1 over 16 here? My answers. Maybe I'm 1 here, but I don't know. Let's skip to another one. Why we have a negative? I don't know why, but let's skip to another question. Next question. Maybe Photomat is 1. I don't know. But let me do the next question. Number 15. Integral of, this is a little bit hard. I'm gonna leave some space here. 1 over square root of e power of x minus 1 from 0 to ln2. A definite integral is harder. It's kind of harder than indefinite, in my opinion. And then here we're gonna use our substitution with that u is equal to square root of e power of x. So we're gonna square both sides. U square is equal to e power of x minus 1. So 2u du is equal to e power of x dx. So dx is equal to 2u du, and then what is our ex here? Let me go from here. You get u square and then plus 1 is equal to e power of x. You move the 1 to left hand side. Before square both sides, and then you move the 1 here. You get ex is equal to that plus 1. So what's our lower limit? Put it inside. E power of 0 is 1. 1 minus 1 is 0 square root of 0. You get 0. And then put ln inside. You get e power of ln2. E power of ln2 is 2. 2 minus 1 is 1 square root of 1 is 1. So from 0 to 1, and then the original 1 over u multiplied by 2u du over u squared plus 1. So you will see u and u, they cancel each other out, and then you can get 2, and then the integral of 1 over u squared plus 1, you get inverse tangent of u, and you're gonna plug 0 and 1. And then if you plug 0, you get 0 here, and then if you plug 1 inside, inverse tangent of 1 is pi over 4 minus 0. So your answers reduces Your answer is gonna get pi over 2 at the end. I forget to parentheses. I forget to make a box. On my next question, I'm sorry. That's not a big problem. Don't worry. So, what's our next question? Our next question is number 16. The lower limit and upper limit are so bad. I hate this. Pi over 4 to pi over 3 and then the integral of tangent x dx. To integrate, we're gonna change it to, you will see why I say that lower limit and upper limit are bad. Because they are not 0 or 1. 0 is really easy to do than that's this. So you get secant square minus 1 here, according to our identity. So if you integrate it, you get tangent x. Don't forget to put the upper limit and lower limit inside and then subtract x, right? Put pi over 4 and then pi over 3 here. So you will get tangent pi over 4, you get 1. It should be pi over 3. Tangent pi over 3 is square root of 3, right? Square root of 3 and then subtract tangent pi over 4 is 1. And then subtract, put the parentheses here, and then pi over 3 subtract by pi over 4. And then 180 degrees, right? This is 60 degrees minus 45 degrees. Let me do it. This 60 degrees minus 45 degrees is 15 degrees. Convert it to radian. Just multiply by pi here, and then you get, reduce this 5 times 3, and then 5 times this, you get 5, 3, and then 15, and then use 36, and then reduce this once again, you get 1, and then 12. Pi over 12. So your answer is square root of 3 minus 1 minus pi over 12, and that's our answers. Yes. Yes, correct. The last 4 questions, it will be much harder than this one. Number 17. The integral of -1 to 1 and then e power of inverse x, and this is equal to 0, and don't do that. This is not correct because this is not an r function or a e function. Be careful. You don't see if the lower limit is -a and the upper limit is positive a, and don't just put 0. You need to change whether this is a function. What function is this? The entire function is e power of inverse x. If you put negative inside, you get e power of negative inverse x. Negative is here and not here, so don't do that. I thought dx. Of course, we have a dx here. So, how can we integrate it? It seems like this is an impossible integral, right? If it is an indefinite integral. But even in the indefinite integral, this integral is possible. And this is not an elementary integral, and this is possible. This is elementary. And you can do it by indefinite. And okay, to integrate, we're gonna let u is equal to inverse psi x, and then our original is just psi u is equal to x, right? Not dx. And then we can differentiate both sides, you get cosine u du is equal to dx. So what's our lower limit? Lower limit, psi inverse psi of -1, you get negative pi over 2. And then put 1 inside, you get positive pi over 2 here. So the original e to the u and then multiply by this, it's just cosine u. What's cosine u du? Cosine u integral of e to the u cosine u du. Of course, this is very good because this is my friend. I always see this integral, just replace it with 1/2 e to the u sine u, but this time it's positive. And if this e to the u sine u, you get negative here. And then 1/2 e to the u cosine u, and higher just put a parenthesis, and then we're gonna plug negative pi over 2 and then positive pi over 2 with it. And here we're gonna plug pi over 2 into it. Put pi over 2 into sine u, you get sine pi over 2 is 1. So you get the first is 1/2 e to the pi over 2. And then you're gonna put pi over 2 into it. Cosine pi over 2 is 0. So you get 0 here, plus 0. And then you're gonna subtract another, put negative pi over 2 into it. Sine negative pi over 2 is negative 1. So minus, let me check the answers. Negative e to the negative pi over 2, and then sine pi over 2 is just negative, which we already figured it out. And then minus this, put negative pi over 2 into it, you get 0. So subtract 0 plus 0, it should be plus 0. So overall, you get the same denominator, and then e power of pi over 2, and then negative become positive, plus e to the power of negative pi over 2. And this form is really cool. E to the power of x plus e to the power of negative x divided by 2, and this is also, we can also get cos pi over 2. And that's our answers. Cos pi over 2, really cool. And our pi is actually here. And cos of pi over 2. That's our answers. You can also leave these answers. If your teacher don't know what is trigonometry, what is hyperbolic trigonometric function, you can tell him or her. We have an H here. So these are answers, really cool and beautiful. Beautiful answers. Wash. 3 more to go. Oh, let's move on faster. Number 18. The integral of square root of 1 minus x over 1 plus x dx. So 1 plus x and 1 minus x, why don't we multiply it by the conjugate? You get 1 plus x multiplied by 1 plus x at the same time. So you get the original back, just cancel each other out. And then be careful, you should get a parenthesis here. And then dx. So minus conjugate negative. That's with 1a squared minus b squared formula. Conjugate is 1 minus x and then 1 minus x here. You get integral of 0, and then you get 1 plus x times 1 minus x, you get 1 minus x squared. So square that, you get square root of 1 minus x squared, and then on the top you get 1 minus x squared, and then take a square root, you get 1 minus x here. 1 minus x dx. Okay, how can we integrate it? I would like to split it into 2 fractions here. We know the derivative of square root of 1 minus x squared is equal to, first you get 2 times this, no 2 here, 2 times the square root of inside and multiply by the inside chain rule. Use the chain rule, you get negative 2x here, cancel each other, you get negative x over square root of 1 minus x squared. So I'm going to split it to this 1 over square root of 1 minus x squared dx, and then plus negative. Why I put a negative here? Because over you get that. So you get the integral of 1 over square root of 1 minus x squared is inverse sine x, put 0 and 1 into it. And then we're gonna get plus, this one is just 1 minus x squared, put 0 and 1 into it. First you get inverse sine of 1 is, inverse sine of 1 is pi over 2, right? Minus inverse sine of 0 is 0. And then put 1 into it. 1 minus 1 squared, you get 0 here, plus 0, and then subtract another. Put 0 into it, you get what? 1. Square root of 1 is 1. So our final answer is really cool, pi over 2. But this time we have a negative 1 here. This number 16 question, we have pi over 2, and here we get pi over 2 minus 1. Really cool. We're almost done. Keep going, but things will be very hard later. So, number 19, the integral of this square root of 4 minus x squared dx. And here, if you put negative x inside, you get this even function, right? So 2 times the integral from 0 to 1, and then square root of 4 minus x squared dx. I know we have already do a indefinite integral of this square root of 4 minus x squared, but I'm not going to use that formula. I'm gonna do it by a geometric way. So I'm gonna graph it. And this is our semicircle. The square root of 4 minus x squared is always gonna be positive. We don't have a negative semicircle here. So its radius is 2. And this negative 2 here, and this is a semicircle. And this our y is equal to square root of 4 minus x squared is equation of this circle. And then the area we're gonna find is from original is negative 1, right? Negative 1, and then this 1, and then 0. And the area we're gonna find is this. So because this is an even function, so this area, these two areas are the same. So 2 times this area, 2 times this area from 0 to 1 is equal to the area from negative 1 to 1. So what's the area of this? This is kind of ugly, but don't worry. Let me draw a line here, and this is a right triangle. And here, this its length is 1, and then what is height? Put 1 inside, you get 4 minus 1 squared is 3, square root of 3 here. So first, you get the area of this is 1/2, because this is a triangle, you're gonna 1/2 times base times height. And then you're gonna add another one is, because this is a semicircle, its radius is 2. Let's put 2 and 2 here. And this is a center. The area of center is, area of a center is equal to 1/2 r square theta. We cannot use this formula. All this is equal to 1/2 rs. And this is s, but we are not going to find this s. We're gonna find what is our theta. So let me draw a line here. And this is also a triangle, right triangle, and then this length is just 1, right? And this radius is 2. What's this theta now? You know, we can use our sideways inverse size of 1/2. You get pi over 6. So you get this area is equal to plus 1/2 times its radius is this center radius is 2 multiplied by pi over 6. Don't forget to square it. So you get reduce is 2 and 2, they cancel each other, you get square root of 3, and then 2 and then 4 over 2, you get 2, you get 4 over 6, 4 pi over 6, you get, reduce this, you get 2 pi over 3, and that's our answers of this one. Really cool. Beautiful answers. You get some square root of 3 and then 2 pi or something. And the last one is the hardest one, in my opinion. Hardest indefinite integral. You will make some mistake inside. It's integral. This is the only one. Its limit. Its upper limit is infinity here. And then we're gonna integrate x squared times e power negative x squared dx. So to integrate it, I'm not going to write it as x times something. Let's just use our DI method. We should integrate e power of negative 2x. Don't integrate it. This is impossible to integrate what? If this is an elementary function, so we're gonna let x here, put x here because this is a multiplication, we can multiply it. Then choose this to be differentiate and this to be integrate. The advantage of this, put x in front, you can use our substitution. Let u is equal to negative x squared and then our du is equal to negative 2x. So overall you get e power of negative 2x and then multiply by 1 negative 1/2 here and then differentiate x, you get 1. So you get negative 1 over 2x times e power of negative x2. You're gonna put 0 and infinity inside, and then we're gonna minus become positive, so it becomes plus 1/2 e power of negative x squared, and then from infinity 0 to infinity. So if you put infinity inside, you get infinity, and then put e power of negative infinity, you get 0. Infinity times 0 situation. This is an indeterminate form, so we have to do our limit. And x is opposed to infinity, and then let's do it. X times e power of negative x squared, you can write it as x divided by e power of x squared. If we plug infinity inside this and this infinity over infinity situation, so we're gonna use our L'Hospital rule. So you get limit at x approach to infinity, and then differentiate x, you get 1, differentiate e power of x squared. By the original first, you're gonna multiply by the x squared derivative because of the chain rule, you get this. So if you put infinity over, you get 0. So the first part of this answer is 0, and then subtract, put 0 and 0, never mind, just 0. And then plus here is the no. The integral of 0 of infinity. And because this is an even function, you can change this to 1/2 of the integral of e power of negative x dx from negative infinity to positive infinity, right? And here is our Gaussian integral, and this integral is square root of pi. So over you get square root of pi over 4. Really cool. And that's our final answers. Okay. Here is our final result. I'm gonna drink a cup of tea to enjoy myself. This is my prizes. This answer is really cool. We got some we get a lot of pi here. You see, it shows how I love pi, how much I love pi. It's pi. We have a pi, and pi. Wow. Honestly, pi in a indefinite integral is really common because you're always gonna get inverse ix and then inverse tangent x and so on and so on. So that's our final question of the video, of this video of the 20s integrals. And peace out. We're gonna do more question. This time we're gonna do some derivative. The derivative will be a little bit easier. Bye.